Okay, this is section 5.6 on page 248. We're talking about special cases here. Perfect square trinomials and difference of squares. Do you guys remember talking about this as a shortcut? You guys remember that? Remember seeing questions like this and I taught you how to go from this in one step to the answer? You guys remember this? So if we have this expression y minus 5 squared, we can go from here directly to y squared minus 10y plus 25. Okay, and the way we did that is we used this formula. Okay, so that's the shortcut from this to this, right? Because what we learned when we had this term is that the middle term, they always added up together. Okay, so 6h and 6h, they're always the same. 3x and 3x, they always added up. So because of that, we could summarize them as being 2 times the product of the square root of the first term times the second term. Okay, so all we're learning today is going from this way the other direction. So we learned this way, the shortcut going this way. And today we're going to learn the shortcut going this way. So expand and simplify. Shortcut was this. And today we're going to learn the factoring shortcut. We're going back the other way. Okay, this is a special case. Okay, and these are called perfect square trinomials when you can go from this to this. Okay, this is a perfect square trinomial. So the first thing I just want to show you is that each one of these, when we expand it, so this is the long way. We expand it, we get to here. Okay, so you can all follow this. X plus 3 squared is x plus 3 times x plus 3. We use distributive property to multiply this out, or FOIL. Okay, and we get this term, and then we gather like terms when we get here. Okay, so each one of these examples is just showing you this formula. Okay, it's either a minus b squared or a plus b squared. All right, so each one of these, we're going from here, you should be able to follow directly to here. Okay, so it's going to be a squared, 9b squared, negative 2 times the product of these. So the product of these is 15b. So 2 times 15b is 30b. And because it's negative 30b plus 25. Okay? So going from this step to this step, we've already learned the shortcut for it. Okay, so what today I want to show you is, first of all, how to identify when it's a perfect square trinomial, and then how to go back from here to here in one step in factoring. Okay, so just like we did the long way here, we can always do the long way going the other direction. So let's do that right now. So x plus 3 squared, is this expanded. So we're going to factor this the long way. X squared plus 6x plus 9. So if we go ahead and factor this the long way, we know that there's no variable in front of the x squared term. So we can go directly to m and a in 2 sets of brackets. M is going to be 9, A is going to be 6. If we know the numbers right away are 3 and 3, they add to 6 and multiply to 9. We can do that right away, x plus 3 and x plus 3. When I say it's a long way, it still was only 2 steps, but we know x plus 3 is just x plus 3 squared. X plus 3 times x plus 3 is x plus 3 squared. So one extra step to get to here. Okay, but now I want to show you the shortcut way. All right, so the first thing we need to do for each one of these, so what I'm gonna do here is I'm gonna erase the middle. So I've convinced you guys that you can do this in one step. We're actually gonna go and look at this backwards. Okay, so I'll erase this entirely because it's up there. All right, so we want to go from this expression now. We're asked to factor. Okay, so we're given this expression. So typically, up until today, what you guys would do would be M and A over here, as we just did. What I want to teach you today is the shortcut. So the way to identify whether it's a perfect square trinomial, the first thing you need to do is to check whether the first term and the last term are perfect squares. Can anybody tell me what a perfect square is? Steven?
It's basically a number that can be square rooted into a whole number.
Yes. Okay, that's a perfect square. If the square root of the number is a whole number, it's a perfect square. Or also a whole variable, we can think of it, okay? Because x squared is a perfect square because the square root of x squared is just going to be x, okay? So if we had x to the 3, this is not a perfect square. This is a perfect square because it's just x. This is also a perfect square because it's x squared, okay? Any number or variable for that matter that can be square rooted into a whole number or a whole variable. That's a perfect square. Okay, so just like our numbers then, we know our perfect squares are 1 because the square root of 1 is 1. Our square root of 4 is 2. Okay, square root of 2, not a perfect square. Square root of 3, not a perfect square. Okay, so your perfect squares, you know them are 1, 4, 9, 16, 25, 36, 49, 64, 81. Okay, these are all our perfect square numbers. 100, yeah. Matthew.
So there can't be any negative.
No. No. So the middle term can be negative, okay, but the first term and the last term cannot be negative. Okay, good question though. So, if we identify that the first term is a perfect square, sorry Stephen, yeah?
I was going to ask, can the first term have a coefficient?
Yes, it can, yeah, as long as it's a perfect square.
Oh.
Like 25, it would be the perfect square. 25x squared is 5x, okay? Be careful though, this is also not a perfect square. Okay? Why? Because 25 is a perfect square, but x is not. Okay? But this is a perfect square. Okay? Any questions there? All right, so perfect square, yes. Perfect square, yes. That's your first test to see if it's a perfect square trinomial. Makes sense because if it's a perfect square trinomial, your first and last term need to be perfect squares. The next thing you need to check is if the product, so this square root times this square root times 2 is the middle term. And don't worry about the sign, if the sign matches or not. So you need to check if the square root of this, which is x, times the square root of this, which is 3. So 3x times 2 is the middle term. If it's the middle term, perfect square trinomial. Okay? That's how you check. Once you've made that check, if it's a perfect square trinomial, to go to the factored form, you take the square root of the first term, follow this sign down, so this sign becomes this sign, and the square root of the last term. Okay? And square it, and you're done. Okay, so now if we have a question like this, 4h squared plus 12h plus 9, the first thing I'm going to do is 4h squared a perfect square?
Yes.
Yes, it's 2h, right? Is 9 a perfect square?
Yes.
Yes. Is 2h times 3 times 2 the middle term? It is, right? Most of you can do this in your head, right? 3 times 2h is 6h times 2 is 12h. So this is a perfect square trinomial. If it's a perfect square trinomial, I'll take the square root of this, which is 2h. I take the square root of this, which is 3. And I use this sign, square. I'm done. Okay? That's all there is to it. Perfect square trinomial. We'll do a couple more here. K squared plus 14k plus 49. Perfect square?
Yeah.
Perfect square?
Yeah.
What's the square root of this?
7.
What's the square root of this? 7k times 2 is? This is a perfect square trinomial. So you take the square root of this, which is k, square root of this, which is 7. Follow this sign, not this sign. This is always going to be a plus, but this sign, plus. Done. Okay? Going over here. Perfect square?
Yeah.
What is it? 3b. Good. Perfect square?
5.
Yep, 5. 3b times 5? 15b times 2? 30. Perfect square trinomial. So we got 3b, we got a 5, and we got a negative sign there.
Squared.
That's it. Okay, this one. Perfect square, yes. Perfect square, yes. Y times 5 is times 2 is 10, yes. So this is going to be y minus 5 squared. Matthew? No, there is no word. It's a shortcut. Okay? If I asked you to verify, how would you do that? How would you do it? Yeah, you expand. You expand this. Okay? And you could expand it using the shortcut too, right? Y squared minus 2 times 5y minus 10y plus 25. Okay? Alright, so that is perfect square trinomial. So that's the first part of the lesson. Pretty easy. The next part is called a difference of squares. Okay? The difference of squares is just like how it sounds. It's when we have a difference of squares, right? So in this case, they typically don't show you the square on the second number. But I've chosen to show you that. So 81 we know is just 9 squared. So again, it has to be a perfect square number. So perfect square and perfect square. The difference now when we go to factor these is there's no long way to do this. There's no way to factor this. If I just looked at this and I told you guys, factor, most of you would say cannot factor. And the reason why is because there's nothing in common. Right? There's no x variable in common. There's no number in common. You can factor out a 1, but that won't change the expression. So, there's no long way, there's only a short way. When we have a difference of squares, this is actually x squared minus 9 squared. And you don't have to write that step out. If you can recognize that 81 is 9 squared, you don't have to write that out. Okay? But that's a difference of squares. Difference of squares is just the square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. And that's it. Okay? And it doesn't matter which one you put first, but one has a positive and one has a negative. Okay? So when we look at this term here, 25d squared minus 36, this is going to be the square root of this term, 5d, minus the square root of this term, 6, times the square root of this term, 5d, plus the square root of this term. And that's it. Okay? And if we wanted to verify, we could multiply this out, right? 25d squared positive 30d minus 30d negative 36. These cancel. You're left with 25d squared minus 36. Okay? Any questions for difference of squares? It's also pretty straightforward. Y squared minus 64, this is a perfect square. Perfect square, it's a difference of squares because we're minusing the squares. Y squared minus 8 squared, y minus 8, y plus 8. Same thing here. 4k, sorry, this should be 4k here. 4k minus 11, 4k plus 11. Any questions? Alright, let's see. We'll do a few more. Let's do 4 more. So we'll do x here. Okay, so first things first here. X squared minus 100. Perfect square, x minus 10, x plus 10. Done. Next one. 98a squared minus 450b squared. Right away, you should always try and factor out any numbers that you can. Okay, here you should recognize that you can factor out a 2. Okay, 2 is common between those two numbers. They're both even numbers. So leaving that 2 on the outside, now we can factor this. This is a perfect square. This is also a perfect square. So what's the square root of 225?
15.
15, good. So 7a minus 15b, 7a plus 15b. Done. Okay, so this is difference of squares. Now looking at perfect square trinomials. Perfect square, yes. Perfect square, yes. Square root 3 times x times 2 is 6x. This is a perfect square trinomial. I can go to one set of brackets and take the square root of this, drop this sign down, square root of that, squared. Done. Same thing over here. Perfect square, yes. Perfect square, yes. 6 times x is 6x times 2 is 12x. This is a perfect square trinomial. X, 6. This sign drops down, squared. Okay, so to summarize, you're going to always look for a common factor first. So difference of squares can factor. Guys, copying this down. Okay, and then finally, a perfect square trinomial. Okay, so the two perfect square trinomials, one with the positive and one with the negative, and those are your two results. All right, if there's no questions, you guys can start your homework.